part three of the discussion of last week's events, 12.4 to 12.8, week 12.4 to 12.8. I'm going to talk about AI in specific, and just for reference, I'm actually at the airport right now flying to New Orleans for New 2023. So that's really exciting. Expect updates from there, hopefully new insights, hopefully some of the big questions that I have. How can we create generalizable robots, physical embodied intelligence, intelligence that is not task-oriented, intelligence that is built to learn, build a child's brain, and then teach the machine how to do whatever it needs to do. So some of those questions are going to loom big for me. But let's talk about the events. I'm going to talk about three lectures, but before I talk about the lectures, just two general concepts, let's say. One is, like I said, so I think the more I research robotics, the more I talk about the issues there, and that, I think I'm getting to the point where I'm asking myself, why not just build a machine that is designed to learn? And what I mean with that is forget the tasks. Okay, what if we focused on learning, just learning, right? What if we took the process of acquiring tasks as the thing to optimize for, and then we teach the machine, like we send it to school, right? We make it learn. So very, very similar to human. Like this would be my first thing. And then the second thing is the idea of grounding AI in sources. There's going to be a talk that I talk about. Douwe Kiela, actually, he's a researcher and also either former or still current professor at Stanford. So grounding AI in sources, that's RAG, Retrieval Augmented Generation. That is certainly good. It helps with hallucination testing, but does it help with truth? So those will be the two general comments. The three lectures: Luca Carlone, Hierarchical Representation for Better SLAM; Douwe Kiela, RAG, Retrieval Augmented Generation; and Adam White, Continuous Learning. This is not even on podcast. It's December 12th, 2023. This is Krim Telco. Since the last update, we're down 4%. The market's up 20 basis points. For the year, we are up 104.5. The market's up 20.5. We're outperforming by 84%. So before I go into the events, let me discuss some general points that I gathered from last weekend. I want to start with the idea of building a child's brain. This is Alan Turing back in the 50s. The idea is very simple, right? Like, why don't we focus on learning and not on tasks? And this is very similar to human learning, right? When we teach kids in general, what we do is we keep them task oriented. Like whether it's teaching soccer or football or math or French, we tend to teach them some theory or some concepts, and then we go into practice. If you ever taken a jiu-jitsu class, the typical format of a jiu-jitsu class is the coach will show you a move, and then you will practice on a person, right? And that makes a lot of sense. Now, that's how robotics is working, more or less. If you look at most recent robotics research, typically a paper is written here's an idea, here's a model, and here's the experiment, and that's fine. But what I'm kind of morphing towards is maybe we should step back and think about, okay, what does it actually mean to learn? What is the infrastructure we need to build for machines to learn? Let's think about this is I'm leaning a little bit on Sergey Levin here, but it's not exactly what he's saying, right? He's a little bit different, but it's leaning on him, because what I'm thinking is, okay, let's imagine a fleet of robots out there that is able to do tasks. How can they continuously learn? How can they get smarter about their environment? And maybe we should do some architectural changes today and think about maybe teach the robots how to learn, right? So instead of being task oriented, how about we're learning oriented? How about we build algorithms that teach robots how to learn? This would be my first comment here, and I'm going to have to dig a little bit deeper here, of course. That's also part of the NeurIPS experience, hopefully, that I'm going to be able to find maybe people who are interested in this type of field. That's why I'm going there. So again, to summarize, like, focus on learning and teach the robots how to learn. Like, what does it take to be able to learn, right? That's a pretty deep discussion, so I don't want to go too much into it right now, but this will be my first comment. So let me start with Luca Carlone. Luca Carlone, he talks about robots in a sort of emergency setting, and what the problem that he's attacking in his lab is, how can we make robots more semantically smart, like more oriented towards understanding semantic nuances. So, for example, go to the second floor and look under the beds. You might find something there. Or there's a fire in the house. Look for humans that are breathing. Don't waste your time with humans that aren't breathing anymore. Like things along those lines, and that requires. According to Luca, the way he's solving the problem is through hierarchical representation. So that will be, I guess, the way I understand his papers and his presentation. He works with a hierarchical representation. So he starts with the base, which is pixels, coordinates, and then he forms objects, stairs, chairs, and then he forms rooms like living room, bedroom, and then floors, third floor, fourth floor, house, block, city. Like it's a hierarchy. And I wanted to ask him the question, but I couldn't. He was surrounded by people, unfortunately. But the question will be, let's say, it's kind of back to my first point, right? How about we stay away a little bit from tasks for a second? How about we teach the robot how to learn, and not encumber it with hierarchies, not encumber it. Why does a chair necessarily belong to a room? Maybe a chair in some other setting has a different representation. A chair is just something you sit on, and it's in the same category as for example, a rock on a beach can have the same function like a chair, but a rock in general is not like a chair. A suitcase on an airport has the same function as a chair. So if we abstract a little bit more, if we look at things from that perspective, hierarchies could be encumbering. Like it almost feels to me like backdoor hard coding or symbolic AI again. Like we're going full circle from symbolic AI and hard coding to full-fledged deep learning, and now Luca wants to take us back into some sort of hierarchy, and I'm not sure that's the right path, but nevertheless, I mean, he's pretty popular. I'm very interested I'm interested in his work, and it's always good to be exposed to these ideas. Next, Douwe Kiela. He's with a company, Contextual AI. He was professor. I'm not sure if he's still professor at Stanford. His talk was about RAG, Retrieval Augmented Generation. I personally think that's really, really amazing, because if you think about it, what he's trying to do is he's trying to build a generative model like ChatGPT or Llama or whatever, and then also do a search parallel to the retrieved or to the generated answer and ground it. That's the idea. So grounding is the idea. And I think grounding in general is a big theme. It's part of his PhD thesis, actually, where he worked on grounding. Douwe's PhD thesis was about sort of how to extract meaning from text, addressing for some of the problems, sparsity, noise, what if a word is rare, but it has a lot of meaning? Preposterous universe, for example. Okay, the word preposterous is rare, but it's really important in the context of preposterous universe. So how do you deal with that? He's working a lot with embeddings, with fusing, multimodal, like that's sort of his angle. And recently in the talk that he gave at Stanford, he spoke about statistical significance and grounding. In one of the ways you can ground any kind of generated AIs is simply by by doing a search, right? You do a search and you find the most relevant links towards the generated answer, right? You can say, this is my generated answer, and this is what it's backed with. And that way you can test for hallucination, because you can flip this around and you can say, whenever I have a generated answer and it's not grounded in some sort of linked, I don't have any sources here, then maybe I'm hallucinating. Now, this is, of course, in some ways very valuable, but in other ways also almost dangerous, right? Because now you're also limiting the system to give you maybe creative answers, or maybe hallucinations are good. So those are the kinds of questions. Nevertheless, I think interesting, particularly also when I dug a little bit into his recent papers and the PhD. So sparsity, lots of words occur very often, some very rare. Noise is, of course, what is a true distribution of words? We can have gibberish, blah, blah, and this and that. And is that really relevant for a model? Should a model be focused on that? Like those sort of questions. And then, of course, like the preposterous thing, like what if a word is very rare, so it has very little meaning? So how do you represent that? And associated with this, I think I have a comment also, or a question, which is, of course, well, one thing is grounding, right? One thing is grounding, but what about the truth? That's different, right? And Kiela, I asked Kiela about that, and he said, look, about the truth, in other words, look, I can use links to ground my generated response. I still don't know if it's true. And one way to hack the system is to create 1 billion documents or whatever, a massive amount of documents that says, President Obama was never, Barack Obama was never president, right? So then the model statistically will say, well, no, this person was not president. You can create fake documents, for example, and you can link to those. So you have a grounded answer, which is wrong. How do you account for these things? There are ways to do that. Crypto has solutions to that. Right now, we're still working with, I would say, almost legacy methods, such as, Wikipedia, New York Times, like the sort of the paper of reference. So we're still using old school. We're using old school. So the question of truth is, I would say, still an open problem, and I think it's an interesting area of research where also crypto can help. Of course, that's expensive, computationally expensive. So I think that would be a really interesting area of research in general. Lastly, I want to mention Adam White, University of Alberta. I wasn't really sure about this presentation. It sounded to me a bit, flashy. Now, the question that he's asking is really interesting. How can we build a machine that continuously learns, that doesn't forget? In other words, how can we add knowledge to a model without jeopardizing what it's already learned? Like, those are canonical problems in robotics. The way Adam presented it is almost like he has the solution. He's the first to ever, tackle this problem and those sort of things. And it just came across a bit flashy, in my opinion. Now, apart from that, so. In other words, I wasn't very impressed with his, presentation. Just I felt like there was a lot of flashiness and sort of overselling a fundamental idea that everybody's working on. I've kind of felt like also the professors and students in the classroom were feeling the same thing. Listen, dude, we know this. Like, what's your solution now? Looking at Adam's paper that he presented, which is about water treatment and things like that, you have to say, look, okay, fine. In general, look, every problem in AI could be almost represented as a reinforcement learning problem, because you have an agent that is acting, and then the environment is usually changing, sometimes based on the agent's reaction and sometimes based on other things. That to me was actually almost the wrong way to phrase it, because the way Adam phrased it is that the agent is very small relative to the environment, so then the environment is always changing. I would say that that's not even true in most machine learning, in most, excuse me, AI settings, particularly in robotics, right? Particularly in robotics, you have the opposite. When the robot does something, it does change the environment. You know, if a factory robot picks up a piece and puts it on a table, then the environment has changed quite a bit. And therefore, you know, if one of Luca Carlone's robots goes and saves a person from a burning house, that environment has changed dramatically for this robot and every other robot. So I would even turn it around, and this is again Sergey Levin's comment, which is every problem in the end is a reinforcement learning problem, even a classification problem. You know, maybe not image classification, but even image classification, even there, like if I classify this as a cat, and maybe this borderline picture is also a cat, then the next generation of models, or the next layers, which will then be fed the new type of data, will have new information about the environment and therefore has to react. So I'm really I kind of disagree with most of what Adam was saying. Plus his flashiness, I wouldn't say he's a. I just almost felt like he's a bit of an imposter. That's how far I would go. But nevertheless, even like this is the beauty of academia. Even in that kind of setting, you can still learn, you can still get inspired. And you know, let's say I read about scaffolding. Scaffolding is the concept of building this scaffold for a model that has all the ingredients necessary that it takes to create a successful machine learning model. So, for example, we have enhanced learning such as curriculum learning. You know, presenting AI models with increasingly complex tasks. So kind of like the way we teach kids math. Transfer learning, learn, you know, one robot learns how to pick up, the other learns how to walk, and then take from the walking to the pickup and the pickup to the walking. Human in the loop. We spoke about this in the context of Fei Li in particular and others. Then we have improved data quality. That's part of the scaffolding. How can we do, you know, synthetic data, data augmentation, interpretability, explainability. That helps building new models if you understand how they work. Support human AI collaboration, imitation learning, training. That goes back to my robot school, actually. You know, so I think scaffolding can almost be expanded into the conversation of building a robot that knows how to learn. You know, focus on learning. So this would be my takeaway. So again, like even though I was not very impressed with Adam, his academic and personal contribution, I think is limited. I think the inspiration is still there. So to summarize, the three talks. One is Douwe Kiela about RAG, you know, retrieval augmented generation. We have Luca Carlone, hierarchical representation of robots to solve the SLAM problem or enhance the semantic capability of SLAM, and Adam White talking about the sort of continuous learning problem. But my biggest takeaway from this set of lectures is really, how about we focus on build a child's brain? How about we focus on learning, teach the robot how to learn, and then we go to the task space. Thank you.